what, yeah, I'll click continue recording, what the future is telling us about manufacturing industry and how many parts, new feature going to be in the upcoming models. That's great news. And as for the automotive industry, you can see it started with about 30,000 parts for a standard car, and it goes up to 60 for a hybrid, and for the autonomous car, it's going up to 80 parts. Again, this is a great news. The manufacturing industry is growing, which is very great, news for us. And this is only two industries, let alone medical, oil and gas, defense, consumers, and many more. If we look into the next slide, every 20 seconds, not in the COVID time, but every 20 seconds, iPhone was built. And you know that average time to keep cell phone in our pocket is about 30 months. So take all together the market growth and the replacement, and you have the numbers. So I believe that we are all in agreement also that outsourcing is not going back to be in-source or insourcing by the OEM. And the future of the manufacturing is really, really bright. But with this great news, there are many new challenges added and to continue to be added frequently. Parts getting smaller, much more complicated, very high precision, new materials, new regulation, higher quality standard increased, but not less important, the manufacturing industry required shorter time delivery, cost reduction, and you know this pressure on a daily basis, and of course growing competition domestically and globally. Now, if we're going to take a quick look on the call it the smart factory. Sorry, I think I jumped one slide. Yeah. If you look shortly on the revolution or the industry 1 to 4.0, just come quickly as a refresher. The first revolution started from the mid 18th to the 19th century, like the beginning, when the invention of the steam and water power came to life. This brought human activities from focusing only on agricultural, also become an industry society. So we're going to make parts. It's not just agricultural. Talking about industry 2.0, which kind of like from the end of the 19th on the mid 20th centuries, then electricity developed that helped us to create what we call the mass production. And then the industry 3.0, when electronics and computerized stuff started to be in place. And now we are in the 4.0. And this initiative, it's a technology innovation that we are live into. It's the Internet of Things, it's the big data, it's the smart factory, which we are part of it, of course, electric vehicle, robotics, you name it, it's there. And when we take a quick look into the smart factory, okay, and that's kind of a illustrated image. Well, I'm clicking on the button, and then everything happens automatically with no or minimal people intervention. But the biggest question for us, can quality be part of this automation today? And here are a couple of questions that we need to ask ourselves. Where does quality actually data fits in this picture? What we are really doing with the collected data today? Is the collected data today mainly used as a go, no go for a part quality? Can real-time data collection will improve quality process, save time, money, scrap part? How we are collecting data today? I mean, the list is very long, and I'm sure that you can add additional many questions about the quality within this nice picture that we see here. But here is like real-time kind of an example. Here is a shop floor, and we all recognize in different sizes, number of machine, but it really doesn't matter, as manufacturing and quality processes are actually similar. If we are taking a part, and let's say we need to do 5 operations to make this part, as an example, And we need to collect data from the part on the following needs or requirements. I need to do in-process inspection for certain operation, which done on-site. I need to do in-process inspection for parts that's done outside, like plating or heat treatment or whatever the case is. I need to collect SPC data for internal analysis. I need final inspection. I need reporting. I need SPC data for my customer. And there's a big difference between SPC for in-process and SPC for customers. And again, the list can be much longer. And this is just kind of a quick example. There are, as you see here, of course, on the picture, there are hundreds of inspection tools types, tens of thousands of measurement tools, from manual to Bluetooth, wireless, CMM, vision, arms, laser, and the listing's long, as by the way, it is growing daily. The biggest question is not about measuring the part right, but where this data goes. Either it is written on a piece of paper or typed into Excel or clicked by Bluetooth device or by CMM vision arm or by any other 100 inspection tools we use to measure our part from start to finish, okay? So there is another layer, of course, which is like not just collecting data, it's analyzing the data. And there is a new popular requirement, as I mentioned before, which is the SPC. And when we look into the statistical process control, the SPC, it is industry standard measuring and controlling quality for manufacturing processes. And SPC is growing demand by the OEM from their supplier, and it is adding a significant burden and cost that require expertise and another software solution in many cases, among many others that are already part of the quality process. And here we have the same question: where this data goes and what benefit it provides. It is just about generating data, it's about quality, trusted data. And it is about integrated and synchronization data and get you analyzed data so you can take a decision, and not getting data to have it registered somewhere and then keep the quality industry or the quality department as only a go, no go step. One of our larger customers, which is an OEM, shared with us the following.
I think Sam's mic got unmuted, or it's muted.
Yeah.
Sam, we can't hear you, Sam.
Yeah, he won't be able to hear us either. Amit, can you take a look at that? Yep, hold on. Yeah, I don't know. Amit, are you
Still with us, Amit?
are you on the call?
Oh, okay. Sorry, guys. We will fix it in a minute or two.
Yeah.
Okay.
See if he sees that.
Can anybody hear me?
There you are. You're back now, Sam.
Oh.
Yeah, we
Why?
lost you a couple slides back. We've been trying to get a hold of you.
Oh. I got a call from Amit. How come that? Where did you lose me?
Go back 2 slides, I think.
Sorry. How come? Okay. From
Yeah.
here, kind of?
Nope, one
Uh,
slide forward. We lost you during the SPC slide.
SPC.
Okay.
There you
Just
go.
a minute. Okay.
All right. Sorry. Not planned to be like this, but that's, you know, internet. So I mentioned SPC, and SPC is an industry standard, which is a methodology of measuring and controlling quality for the manufacturing processes. SPC is a very or highly growing demand by OEMs from their suppliers, and it is adding a significant burden and cost that requires expertise, and in many cases, a different package of software among many others that are already serving the quality industry. And the question is, when we are talking about SPC, what value we are really getting from SPC except of sending data or SPC results and chart to our customers? We say if you are using SPC, do it also for in-process inspection. And it's better to do it because all the way is like, are we go, no-go department as a quality department, or we can add value to the process. So it is not about generating data, collecting data. It's about having data on time when you can influence or impact the process, correct it real time, and not just having as a history, and which is in many cases too late and too expensive. And just talking about data and what we do with the data, I will quote one of our customers, which is a very large OEM, and that's what he has to say. I have a lot of data, but I do not have information. My data is spread all over this place in endless software, folders, as well as with hard copies in boxes, report, plans, in-process inspection, results, SPC, engineering change, and you name it, we have it. And my concern, as he continued to say, that one of my customer will come and complain on a part that he got 6 months ago, and I'm going to spend now 2 weeks to find the data all over the place, even in folders on electronic device, or definitely in boxes in my attic. And I need this data when I need it, not as a historical data. So talking about key success factor. The key success factor is to have an all-in-one quality management system that has all those components that you see here. And actually this slide represents in a high level, the entire quality industry problem, but on the positive side, the solution. All-in-one integrated quality management software is a key success factor. Here is an example. Let's say for in-process inspection, which it's done mainly by the shop floor guys, why instead of writing results on a piece of paper or on a physical print, or even click it on a screen to a non-integrated quality application, right? Why these clicked results will not be real-time in the quality database, and with real-time results analysis providing real-time visual data to the machinist on the shop floor, so he can fix it, or maybe other people who related to this project can fix it on the fly and not wait until the end of the process and said, oh, we have a problem, oh, we had a problem. So the way high QA looking on valuable inspection results, not as an history to be stored only, but to take action real time when it is not too late. And this is only one example, of course. Kind of quickly, this is all everything start. It start on a 2D print. And as you probably know, most of you, and I believe that Chris will show you something on the real demonstration, we don't do ballooning by pen or pencil. We don't extrapolate or interpret it what it is there. When you click auto balloon, GD&T, and PMI. The system extracts in minutes all the information that is required to a bill of characteristic, balloon the print. You see on the left side a small list of ballooning, GD&T recognition, bill of characteristic, inspection plan, and then it takes you to other activities that are very critical and important. For instance, in-process inspection, manufacturing operation, bill of material, and all other activities that required, as well as integrated inspection tool. And in the inspection tool that you see here, it's also all in one. We strongly believe that inspection tool, gauge, micrometer, caliber, should be an integral part of your quality process. I don't want to get inspection results for the tool that is out of calibration. And it's easy to do it when it's all in one. And of course, as I mentioned, when you have inspection data, it's real-time get analysis, either in results or in SPC. And then, of course, we're talking about data collection. And data collection can be done from any inspection tool in the globe, either generate digital results or Bluetooth or wireless using keypad like you see on the right screen, either on a PC or a tablet. And it all goes real time into the quality centralized database. That's why it's enabled and it's available real time to anybody who relates to this job. And of course, the end of the process, we get the report, any type of report with one click. Kind of summarizing it before I'll transfer it to Chris, database-driven application and all-in-one is extremely critical, and people knows it from ERP or CAD/CAM or other enterprise solution, because when you store everything in a database, it's available in different format as SPC, as report, in process inspection, alerts. Whatever you need is there and real time. Kind of with that opening, I again want to thank you for taking the time today. And I would like to transfer this presentation to a Chris. Chris?
Yeah, thanks, Sam. Okay. Take the presentation rights, and if you guys could verify that you're able to see my screen okay.
Yeah, we've got you, Chris.
All right, thanks, Jack. Okay, perfect. So, yeah, what I wanted to go through today was just a quick kind of overview of practically how some of these things that Sam is talking about play out in Inspection Manager. So we wanted to do a focus on data collection from the shop floor and how all of that comes into a centralized database and how we can view it and manage it and so on and report on it. And then within that, there's kind of planning steps to how do we actually get this down to the shop floor so that we can appropriately inspect our parts and collect that data back into the system. And so I want to start just on the planning side. So for those of you that are brand new to Inspection Manager, you can kind of see that we have a balloon print here. And we've got our bill of characteristics down below and a toolbar over here on the right side. And so some things that I've done here, and I'll kind of walk you through the various components that play into the shop floor side, is in our bill of characteristics that we have, we're able to augment these dimensions that we extracted from the print, and we're able to assign things like tool categories, right? We can assign designators, so we can call out which dimensions are critical, which ones are minor, and assign specific frequencies at which they should be inspected. So we don't inspect the entire part every single time throughout the production run. We inspect critical key features, major, minor features at specific frequencies throughout the life cycle or the production cycle. Some other things that we would want to do is break up the dimensions into dimension sets that we use here. So this is just a way of grouping dimensions, because you may want to be able to collect all of your CMM inspected dimensions, all of your manually inspected dimensions, critical and minor, and be able to filter by those in various ways, whether it's reporting or you'll see once we're on the shop floor, how we're able to actually distinguish and know what we should be inspecting at any given stage of the process. We also have inspection procedures that we can assign. This is more correlating to manufacturing operations. So you inspect key specific features on the part as they're manufactured throughout the production life cycle. Okay, so all of these play a factor, and hopefully this just provides you some insight into the depth that we're able to support here for your inspection planning. But all of that kind of feeds into the sample planning side, and I want to talk a little bit about this. So what I've done here is broken up, created a series of samples for 2 levels of inspection. Well, actually 3 technically. So throughout the production life cycle, we're going to have an FAI or a first piece that we end up inspecting, and that's going to be a full inspection with every dimension that gets checked. So you can see under here total results here, so there's 53. And then after that, I have a series of parts. This is over a 100 piece lot that we're performing this inspection. And so I put a little prefix here for production, and it's production 1, 6, 11, 16. Each one of these line items represents a physical piece in the production life cycle that's going to be inspected. And so this is saying we're going to inspect the first piece, the 6th, 11th, 16th. So it's every 5th piece is going to be inspected. And you can see that the results, the dimensions that are going to be inspected for each piece kind of stagger here, because as you'll see in the bill of characteristics, some dimensions get checked every 5th piece, some get checked every 10th, etc. And so we're able to kind of build this automatically so that on the shop floor, they're able to pull up the specific pieces throughout the production life cycle that are being inspected and be informed as to which specific dimensions need to be checked. And so we're basically able to very quickly build these detailed, individualized inspection plans for each part within this process. And then down here, I have a second sublot where we're going to have, at the end of the production, there will be a final inspection so that we can take our bin of parts and randomly select 8 pieces per our AQL that we had for this lot. And so we can randomly select 8 pieces, and we're going to inspect some specific features there. So you can see these ones all have specific features that are going to be checked. Okay. And I already started putting some data into this. And so you can see that there was one feature that was checked across these, and one of them failed that inspection. So we're able to see failed dimensions in this column versus the remaining dimensions in this column here. Okay, so I bring all this up just to show kind of the planning side of the inspection process to be able to stage for the shop floor. So now let's pivot over to our shop floor applications to see what the inspector experience is like. So I'll click into here. So these are our shop floor applications, and the experience is such that as an inspector on the shop floor, I would log in with my user account. I would click login, and through a variety of means that I have, I could pick the part that I'm inspecting at this point in time. Okay, but the easiest way I find to do it is just use a global search. And I'm going to search for my job number that I have in front of me. And so that happens to be job 1. That's the job that I'm working on. This could be a work order, it could be a batch, it could be a lot, it could be however you define the terminology inside your organization. But we're going to call these jobs for right now. So we'll say job 1. Now, when I click into job 1, you'll see I have all those samples here that we just discussed. So I've got my FAI, my production samples. As I scroll down, I've got my last piece and then my final inspection samples. And I can filter by those, right? So I can see my production pieces, I can see my final inspection pieces, and so on. So regardless of which stage of the process that I'm in, I can find the pieces that need to be inspected, and I can perform my inspections accordingly. So let's take a look at this. If I'm in my production inspection here, and I want to pick a particular piece, I may have the FAI that I want to inspect. Okay, so I'll double click on that. And this brings me to a digital inspection plan. Now, most of you, if you're not using some sort of software like this, most of you are probably used to using an Excel spreadsheet and a ballooned PDF, and between those two documents, you're able to inspect the particular dimensions that need to be inspected. So this is essentially those same documents kind of rolled up into a nice, clean user interface where we've got a interactive PDF that's ballooned and shows us the dimensions that need to be checked. And we've got our dimension list over here. And as we select one, it navigates to that dimension on the ballooned print. I can also click interactively with the ballooned PDF. Okay, so this can be hosted or run either from a PC workstation on the shop floor, an inspection room, or on a tablet. Right, and so I've got my details over here. I also have a series of filters up here. So again, depending on which stage of the process I'm in, maybe I have a specific procedure that I'm working under or an operation, depending on your terminology you want to use. And so I can click that and see just the dimensions that need to be checked at that level. And you'll see that it's filtering out the ballooned PDF as well as the inspection plan here to show me just what I need to inspect at a particular procedure. Okay, so there's a lot of flexibility here, a lot of options, and you know, we didn't want to clutter the webinar too much, but there are multiple workflow options within these shop floor applications. So this is just one that gives you quite a bit of broad access to decide what you want to work on. There are other workflows and other sides of this app that restrict kind of what you're able to work on. So there's a little bit of planning on the front end, and then the operator or inspector on the shop floor is effectively just walked through the inspection process and told what he needs to check, how many pieces, which specific dimensions, one by one, etc. Okay, so just as an example here, I'm going to show you, I have really, once I pick the dimension that I need to be inspecting, I have two things that I fill in. I just fill in the tool and gauge that I'm inspecting with. So I can click here, and I've got a couple of filters that are out of place that I didn't fully prep for this, but and I can pick out of my inspection tool library. So Sam mentioned this in the demonstration earlier, that we integrate with your inspection tool library, or we have an integrated inspection tool library built into the system, right? So we can bring all of your measurement tools in, track them from a gauge calibration status, and okay, so sorry about that. From a gauge calibration status, and even from like a location status, we can track gauges throughout the shop floor, so we know kind of geographically, if you will, location-wise, where they are. And so we can pick specific gauges that we're using for an inspection. So I can either search by one, or I can pick from the list here that I have. And so I'm just going to pick a particular one here, say select. Doesn't really matter at this point, but we'll put in a specific result that we are going to collect here and say that, and I'll say accept. You'll see it turns green, and I move to the next dimension that I'm going to inspect. And the tool, the gauge that I'm using, actually sticks. So that way I can inspect all of these specific features that relate to a particular gauge in sequence, and then I can move to the next gauge that I need to inspect another set of features. Okay, so for this one, let's throw in a result that's actually going to fail here. We'll do something like this. And so this time the result failed. So it gives me a notice that the measurement failed. And so I have a couple choices. I can either measure it again, or I can keep it failed, right? And so I may want to measure it again if I have a typo, or if I want to just, you know, make sure that I'm getting a valid reading. And so I'll say keep failed. And here I am now prompted to actually generate an NCR. So this is a hugely powerful function where directly from the inspection, we're able to kick off an NCR automatically instead of waiting to the end of the process, or somebody walks a sheet of paper over to hand over to someone else. Rather than having that delay in there, we're able to immediately trigger these NCRs, right? So I can add a new one in here. I can pick a specific work center that this came off of, or an inspection center that this came off of. and I can even give it a status. So depending on the level of autonomy that your inspectors have on the floor, they may be able to disposition the NCR right away, or maybe that happens through a different workflow with other personnel. So I'm going to say okay to this, and I can assign a particular defect code. Okay, so we have defect codes based on specific manufacturing types or types of manufacturing. And so if I just pick a particular one here, I'll click this one, or yeah, we'll go with this one. I think the previous one had that. So, and I can even see the legend if I forget which what these codes mean. So I can open that up and I can see, okay, there's cutting tool chatter right there for CH. Okay. So I'll select that, I'll say okay. Now, this is the particular defect code, which perhaps there's multiple instances of a defect code or cause. So I can add those. That happens in the case of like welds and things of that nature, where you can have multiple occurrences of a defect. But I can even add things like attachments and pictures if I want to give a little bit more documentation about this particular defect on the part. Okay, so all of this is possible directly from the point of inspection without any sort of delays in between the process. So hugely powerful tool set there. And then I'm able to either move on with the inspection, or I can cut short and perform any other stage in the workflow that needs to come next. Okay, so that is the concept there. Now, there's some other things to look at too here from the shop floor side. So if we're looking at final inspection, let's say, from final inspection, I don't inspect one piece at a time. I would line up a series of pieces and inspect those accordingly, one dimension across all of them. And so I might want to do this multi-serial number inspection here. And so I can pick a particular dimension that I'm going to inspect, right? So I can pick the dimension that I want to inspect. At that point, I can hit select, and you can see it actually gives me a trend for the inspection results that I've gotten. So I'm able to get this sort of an SPC trend in real time, again, at the point of inspection, rather than having to calculate that information later on in the process. So this ties into SPC in process, not just at the end of the process, right? And so I have data that I may want to use to improve my manufacturing as opposed to just the final inspection SPC data that I may want to present to my customer, right? So we're able to distinguish between those things. So all super powerful. Something that I failed to mention here earlier, but we'll bring it up now, is when we're inputting these measurement results, I can do this manually by inputting through the keypad, but I can also I can hook up digital gauge equipment, whether wired, wireless, Bluetooth, etc., so that when I click a button, this field automatically populates. Some gauges, if they're capable of it, can output a gauge ID that'll automatically populate our gauge ID field as well. So that way there's really minimal effort in doing the searching for the gauge and keying in the result. It's highly accurate and much more efficient. So a lot of power in these apps. Okay, so I want to go back and just talk about one other side of this data collection as well, is that manually inspected dimensions are only, half of the equation here. We also need to collect data from our CMM equipment. Okay, so we have the ability to import the inspection data that's being output from our CMMs. And it doesn't really matter what you're using for a CMM. I'm going to show you an example of this just to have here. Okay, I'm going to show you an example of this. I've got a demo file that I set up here for this. So we're going to pretend that this is a file with some CMM results in it. So whether you output like a CSV, a text file, an Excel file, etc., from your CMM, almost any CMM has the ability to do this. We can import using various CMM templates. Now, this is a huge value-added feature that's in our system, is that we're not confined to a specific format or set of formats or types of CMMs. We can integrate with virtually any CMM that's on the planet that will output data in a text, CSV, .dat, Excel type format. It doesn't really matter as long as it's some sort of data-driven format, because on the back end, our teams have the ability to build custom import formats. So the way to think about this is the same way we have a report designer. So you can build custom reports in our system to output your FAIs, your production reports, your PPAP forms, et cetera. You can output those in any sort of a format that you want because of the flexibility of our report designer that we have. In the same way, we have that same level of flexibility for importing the results data into the system, whether it's from CMM equipment or if you have manual inspection planners, okay, where people are filling out like Excel spreadsheets or something for their manual inspections. Yeah, there's some of our lower end packages have that as an option. So no matter where you're getting that data from, you can have various formats stored in your system, and you say, this is the format that I'm currently trying to import results against. So I can go next here. And this will just take a few seconds to import. I should mention that this process that I'm doing right now, this is one of the options. This is a manual import option. And we also have an automatic one that I'll mention in just a minute here. But the idea is it brings in my result data, right? And I can say which lot this is coming in against. I can say a specific sample this is coming in against. Maybe this is for my FAI piece, right? I can bring that in and so on. We can even do this for multi-serial number or multi-sample inspection results. Some CMMs will inspect a whole series of pieces, and then they output one file with results for each of those respective pieces. So we can import those accordingly and associate them automatically with the appropriate samples, sample numbers or serial numbers. So I'm going to say finish here and let that import. Okay, and as I mentioned, this is one method, but you'll see what's happening here is I'm able to overlay those results on top of my ballooned PDF that I have here, and I'm able to see the real data down below here. And so I can see if there's a failed result that came back. I can drill into that. I can see the specific. So this one was the one that we actually inspected on the shop floor, okay, through our shop floor data collection apps. So we had input that failed dimension up here, and it's showing me who the user was that inspected that feature and what gauge was used, how what the deviation is and out of tolerance, et cetera. Okay. And so I can view all of that information, and I can even see up here and under the nonconformances, I can see any nonconformances that were reported against this part. Okay, so all of that data in one place, and something really important here too. Okay, so something really important here too to notice is that this here was collected from our shop floor applications through a manual inspection process. The other results that are in here, like if I look at this one, this failed dimension, this one came from our CMM data that we did an import for. So we imported a batch set of results. And so all of that data, no matter where the source of the inspection result, it's all coming into one aggregated database, one centralized database that contains all of your information. So if we look back at our samples tab here, right, we had all of our samples that we talked about in the beginning. So I can look at that FAI piece and see that, okay, great, I brought in some results. Maybe it was results collected at a particular operation or phase of the process. So I've got 39 remaining, but there were also 2 failed dimensions across that, right? So I'm able to really quickly see across an entire production lot or final inspection lot, I can see kind of the status of those results that were collected, right? So hugely powerful tools here, all in one seamless interface. So from there, let's say that we've finalized the inspection, right, of all these dimensions. We'll say that we walk through the rest of the process there, and then it's just a couple of more clicks and I can output FAI reports like an AS9102, like so. We can also output PPAP reports. Like I said, we have a full report designer to do any sort of custom reporting, but this is just an example of an FAI report that we can show here. So you can see how all those results are tied in seamlessly to one report. very elegantly like so. Okay. And Jack, I think we can go back to you for a Q&A time while we're winding down.
Great. Let me get my screen up to share.
I'm here. I'm here. Can you hear me, Chris?
Yes, I can.
Okay. There is a question here. As long as you are there, no, keep your screen. No, give give back the presentation rights to Chris. We
Chris,
may.
go ahead, take over.
Okay, Chris,
Okay.
take over the screen. There is a question from Anthony, and I think it will be good to show it. This question about is the gauges carrying over across the features? Does it apply to all features right away, or only to the features that have the same method of check? Also, would the gauge carry over to the next part? Maybe there is a answer for it. Go ahead. Yeah.
Yeah, I see what he's asking. So you're talking about the fact that the gauge sticks from inspection check to inspection check. So the answer is both. Yes, both. It depends on which workflow that you're setting up. So it can be with respect to the particular gauge category that's selected through one of the workflows, or it can be regardless of the gauge category in the other workflow. And so it can work both ways there. And then as far as carrying over from part to part, it will carry over before I say, so from sample to sample, I think is what you're asking. And I believe those do carry from sample to, no, the filters carry from sample to sample, but the gauge won't necessarily carry from sample to sample. They do if you're doing a multi-part inspection, but not for the individual pieces, because if you're doing one by one, you're gonna use a few different gauges across the different checks that you end up performing. And then when you go to the next part, you're kind of resetting that process. So.
There is probably another answer to this question, but on the level of tool categories, that you can assign tool category, not specific gauge, but a tool category based on feature, and then it will be automatically assigned, not necessarily the specific gauge, but at least assign tool categories based on a feature recognized. It eliminates, I would say, the guessing of how I'm going to inspect this feature. So yeah, it's a gauge, but not maybe a specific gauge. And you have it in the measurement and gauges. I mean, you can click for a quick second on measurement and gauges, Chris.
Yeah.
And let's do inspection tool category, the default in the setting, not here, in the setting.
Oh, the default tool, I see what you mean.
Correct. Yep. Yeah, here it is. So everybody can set up his own assigned tool category based on feature recognized. It will carry it out automatically when you extract data from 2D print, and the specific tool category will automatically be assigned to this feature. Not necessarily the specific inspection tool, but a tool category for sure. Thank you, Chris.
Yep, absolutely.
There is another question. Can HiQA integrate with MRP software, such as Infor Visual Manufacturing or Sync? Yeah. The answer is absolutely yes. We have what we call open API. It's a standard API. We already integrated with multiple ERP or PLM software through API. And I would assume that, well, I believe 99% of the ERP, MRP, MSE system having API. So the integration is very seamless. Usually when we do this type of integration, actually it's not we do. Using our API, you can integrate and we can get data and we can send data out. And the whole question will be the value of the exchange data between the systems. So that's definitely available.
Yep.
Then there is another, this is from Steve, and this is another from Kyle. For parts we multiply separate machining operation, is it possible to partially balloon or color code balloon dimension for the separate operation? I think the answer is yes, but I will let you answer, Chris.
Yeah, so that's where you have inspection procedures here.
Correct.
So that's one way to do. There's a few different ways to do this. It depends on the nuances of the process, but the underlying answer is yes. You can see here how we've got two different procedures that are correlating to operation steps. And so they color code the balloon areas accordingly. And those filters kind of pass down through to the shop floor so that inspectors can see just the specific criteria that needs to be checked for their operation step. Yep, absolutely. Good question, Kyle.
And you can also do it directly without in-process inspection, just sort by, let's say, feature type and assign to a specific inspection tool. But that's another layer that you can handle.
Yep.
Right. Okay.
Stephen asked a good question here that's pretty easy to answer.
Okay.
So if there's, if you're checking dimensions on a CMM that aren't part of the print, how do we deal with the results coming back from the CMM? So there's two possibilities for what you're asking there. Either there's like an in-process dimension that's not on the print. So for that, we have manufacturing operations. That's another stage where we can actually generate alternate requirements for a particular dimension at an in-process stage. So you could say, maybe when I first check this at the first operation, maybe that's got a little bit of extra material to it. And so I can kind of build those alternate requirements through manufacturing operations. Another scenario that you might be asking about is, what if I just have some visual checks or, alternate inspection criteria that I want to check that's not spelled out on the print, but I want to add it to my inspection plan? You can right click down in the bottom here and you can add dimensions, right? See, and it just gives you a general dimension to start with, and you can define that however you want. Define the dimension type, right, for many of our dimension types that we have in here, and build out the process out that way. And so that becomes part of your inspection plan, even though it's not on the print, so that when you bring the results back from your CMM, it's got a place to go.
There is another way to do it, which I don't think it's great, but it's available, which is, results mapping. And
yep.
So you can show, I mean, if you don't have anything, you have results mapping, you bring all inspection results, you can drag the results directly to the feature on the print. And from that point, it's there as a template if you have multiple inspections on multiple parts. So
yep.
Again, it's not, I don't like it. I don't think it's the right way to go, but it's available in the system as well.
Yep.
I think, do we answer all the current questions? I think we did.
Sam, there is another stream of questions in the Q&A. You are answering the chat questions.
Okay. I'm sorry.
Yeah, I'm
That's
taking
okay.
a look at some of those now. So James asked, is the designator field critical, major, minor, et cetera, purely for reference, or does it have an effect on the frequency of inspection or something else? So that's something that we're going to do fairly shortly. But right now, criticality, one thing that it does, you'll see that I've got some dimensions here, dimension 1 and dimension 15, that have different balloon shapes so that we can easily identify them on the print. So that's actually driven by the fact that those two dimensions are critical. They're marked as critical. So we're driving that right now. And fairly shortly, we will have the ability to drive frequency as well by the designator type. So that's something that's in the pipeline.
Yep. Can you see Steve answer, Steve back on?
Yeah, I'm checking that right now.
If true position is out of limit, how does the system identify the associated basic dimension that needs to be investigated?
Yep, so that's a really good question. So typically your CMM, when it checks true position and diameter, it's going to output multiple results, right? Your diameter, your true position, any other GD&T going along with that. And it also outputs the result for the basics as well, your XY positioning, right? Or your XY axis, or whatever axis the hole is on. And so what we do is we automatically associate those XYs with the true position value when we import the results. So that way you see them side by side, and you're able to, then you can go through a results mapping process if you want to have the basics ballooned. Most people don't care about ballooning their basic dimensions anyway. They just want to see the results that came back from the CMM. So that way they have the positional awareness of where the true position came from, but also the raw data as well. And so that can either, you can really easily output when you do your reports. You can output primary actuals only. So a primary would be the true position, and the basics would not be considered primary. Okay, and so you can, there's filters there so that you can really easily determine if you want those basics included in your reports or not. Because a lot of time your customers don't really care about it. You just want to see it for your analysis. So
there is another question. I will show the answer on Ron question, but there is Clint. If you can answer it, I will address the last one. Can you see it?
Yeah, I think Clint is actually really closely tied to that. And James is asking a follow-up question on the true position. So before we get off of that, James, yes. So James asked, is maximum material taken into account when entering results? Yes. So again, when feeding or reading your results from the CMM, we can account for the max material condition as well. So if we look at this here, you've got the bonus column right here. So I don't have anything populated in there right now, but if your CMM is outputting the bonus tolerance, we'll import it along with the rest of the results.
Okay. Yeah. Now there is a question from Ron. I noticed that auto label feature placed on the bubble next to the feature with multiple calls out, such as thread with size, minor, true position. Actually, the question is there a setting to each individual requirement can be numbered? And the answer is yes.
Yep.
I don't know if you can show it. You have it, or?
Yeah, I can show it. It'll take a little time for it. I would have to re-balloon it because the way that I chose to balloon.
I'm taking the presentation rights quickly from you, if you don't mind.
Yeah, go ahead.
So I have it on, I think, on my screen. Where is my screen? That's the good question I have.
Yeah. Here, I can show the option here in the auto balloon.
Yeah, you can show the option. That's okay.
So
there's
the option here to split the sub characteristics so that, for instance, I think this is what you're talking about, where balloon 17 here, it's got multiple callouts. And so this would balloon as 17, 18, 19 instead of just as a single feature. So some people have a preference there. Now what we do by default is have 17.1, 2, and 3 so that they are unique dimensional checks on the bill of characteristics or in your inspection plans, but they're referenced back to a single feature, so the balloon is relative to the feature. Yeah. But if you're not a fan of that, then we have the option to split sub characteristics.
What are the system requirements for the tablet or PC for the inspector interface? That's Chris, you can answer it, or Effie if you are available.
Yeah.
So
go ahead, Chris. Go ahead. It's very simple.
Yeah, they're fairly straightforward. We have documentation and articles for that, which we'd be happy to get out to you. If you want to reach out to our sales or support team, we can get all the specifications for different environments, server environments, Windows 10, PC environments, tablet environments. We have all that.
The specific are very simple. Off the top of my head, it needs to be the size of the screen needs to be at least, I believe, 8 or 9 inches. Diagonal. Operating system needs to be Windows 10, and it needs to have a USB port. Yep. These are the 3 main primary characteristics.
Oh, yeah, I understand. I actually was misinterpreting that a little bit.
Okay.
I thought for the entire system as a whole, like server requirements and such.
No,
just for the tablet or the PC. Yeah, they're fairly minimal. Yeah.
On the price point, this is about $150 tablet from what we know from customers who bought many.
We are also working to certify it for Android. Mm-hmm. So in the future, in the second half of the year, you can use also Android devices that will take further the price down. of the hardware.
I think there is another question here from Kyle, Chris, on can the frequency of the check during production be set to follow CPK levels? For instance, if CPK drop below, it's like dynamic, if you will. Can you see the question?
Yeah. CPK drops. Yeah, so that's a dynamic AQL type type effect there. So basically your sample plan and what gets checked at what frequencies and such would vary based on real like actual conditions. So based on the performance of a particular feature. And so that can be off of CPK, that can also be off of pass fail, etc. And there's other kind of variables and conditions in there. So that's something that we're looking at over the summer and should be available later on this year. But that is something that's very high priority in our pipeline right now.
Okay.
Chris, there are 3 questions that are still waiting and the Q&A box is open.
Yeah, we're trying to go over all of them.
Yep.
Can you export QIF files? Absolutely. I see Andrew, the last question. Yes, we are QIF compliance. Actually, we were one of the initiators of the QIF team as part of the MSC board. So the answer is absolutely yes. What else do we have here?
James, I think what you were getting at here, James asked, is there a reason the thread information in 17.2 is not ordered in the same layout as on the print? And I think the simple answer is we just have one standard layout for how we arrange this. I think you're talking about UNC 1024 versus the 1024 UNC 2B. And so we just have one standard layout for it. It varies from print to print. Everybody has their own way of doing it, but we just came up with one way of outputting that in our format. So.
But this is, you're talking about the right side of the print, right, Chris?
Talking about, so this, this is 1024 UNC, and ours is UNC 1024.
Oh, yeah, that's what you meant. Oh, right.
Yep.
Okay. Is there any question that we didn't address? Can you record basic dimension for true position? I think we said, okay.
And by manual input to yeah, so any dimensions that you're that you would like to check, whether they're basic, whether they're reference dimensions and standard tolerance dimensions, et cetera, it doesn't really matter what they are. It's all about how you build the inspection plan. And then once you have your inspection plan in place and you set the criteria about what needs to get checked when, how often, by who, you just simply click a checkbox to determine whether or not you want to collect SPC on those. And so when we say that, it's not saying that, hey, from this point forward, because we already have the data in the system. It's been collected from our shop floor applications, it's being collected from our CMMs, et cetera. And so because it's all in there, what we're basically saying is, do I want to chart that so that when I click up here to my SPC tab, I don't believe I actually have anything in here right now, but this would have all of our charted data here for the individual dimensions. And so it's, like I said, it's really just about how you build the foundation of it so that it drives your reporting downstream.
It's a nice question that it will be nice to answer through example.
Yep.
It's talking about Imperial and English, and yeah, I mean, the idea is that you can switch between them like on the fly. Whatever you get from your customer, let's say you get metric and you would like to convert it to inches, and can you centralize the print for a quick second that you have?
Oh, yeah. Yep.
Not here. Oops, you're right here.
There we go.
And click on the 2 arrows, and now you can see what happened.
Yeah, so we've got this option up here to be able to toggle. It's not going to work with the design that I have.
Oh, I got it. So can I take the presentation rights from you? I'll do it.
Yeah, let's do it on yours.
But I need to take presentation rights from you, and which is probably gonna work like this. Yes. I think it is here. Share. You can see my screen, right?
Yep.
Yes, Sam.
Okay. So again, the whole idea when we talk about conversion between units, it's one click, right? That's it. That's metric, that's English. But I would like to emphasize this because we are talking all the time, database, database, database. So what you see here is not a magic. When we extract the data from a 2D print to a bill of characteristic, as you see here, always the primary unit will be here on the left side. We do not wait to anybody to convert the secondary unit on here. So you have automatically in the database, these units are already at the database. So what we did on the print is just representation from the data that we have it already in the database. Okay, so very easy to do. And again, all the decimal point can be, of course, controlled because there will be always question about the setup. So you can handle it very well. If you go to the setting, where is my setting? Disappeared here. Somewhere. But you can set up the decimal point very easily. Do we have more question in place or we?
No, I believe that's all of them.
Okay, perfect.
Seems to be everybody. Anyone has any additional questions, you can feel free to email us at info@highqa.com. You can also call us at 888-727-1266 and listen to the prompts. And of course, you can visit us on the web at highqa.com. I'd like to thank everybody for participating today. It was a very robust session, a lot of questions, which was very good. And I'd like to thank you for being part of our very first Zoom-based webinar. Thank you.
Thank you, guys.
And goodbye.
Thank you, guys. Thanks.
Yep.
Bye-bye.
Thank you, everyone.
Thank you, guys.